I'm going to talk give you a sneak peek into where is the infrastructure headed and what is that infrastructure that you can use for all your e-governance application rollouts and the increasing role that software is playing in the infrastructure space today. We are the 6th largest infrastructure software company in the world, $4.7 billion in revenue with more than 4 lakh customers worldwide and more than 3,000 customers in this country. And many of you know us as the virtualization major, the people who brought in virtualization a decade and a half back. And today, virtualization is seen as the first step to cloud computing. So given that we have kind of pole position in the cloud computing space, but today I will talk about what are the future developments that you could expect from VMware given the kind of investments that we are doing in this area, and how can you take advantage for all your e-governance applications using the latest infrastructure software that we can provide for you. So if you look at the different changes that we have had in IT over a period of time, clearly, as most speakers before me were also talking about the fact that the cloud computing is here for real. And when I speak cloud computing for this forum, I will restrict myself to the private cloud that we build within our data centers. So today, virtualization, if you see, has moved from what was a nice to have a few years back to a de facto way of deploying applications. And the cloud is much beyond that. So I will also try and describe what is the delta over virtualization that the cloud brings in today's world. And if you look at the different phases of maturity that we have had, we were talking about the data center being a museum of the IT past. We were talking about the fact that we have bought systems at different points in time, and today we are struggling to integrate these systems, etc. That is the reactive phase that we are talking about, which is the first phase, where we are struggling to deliver services to business because we have different systems procured at different points in time. Integration is difficult, and there are a lot of vertical silos within our data centers. So the next step is to move to a proactive, which is where a lot of self-service comes in. A typical example is, Madam was talking about the government of Maharashtra having a cloud deployed. So here you have the ability to provide a self-service. So why should we spend time on managing infrastructure? Can't the system manage it for us? Can we make the whole thing a self-service where we go and click and there is a provisioning that happens, where we just define policies and the system takes care of a lot of things instead of creating manual scripts, as Singh Saab also mentioned that why can't we go to the cloud and automate a lot of things? That's precisely what it does, where you're moving to an era of providing a portal to the end user and saying, you manage what you want. And all he does is clicks, it goes through the necessary approvals, and you're there. So we call that IT as a service. That is the next level of IT infrastructure, where instead of providing services, you run it like a business and you say, okay, I will give you these services, and based on your usage, I'm going to charge you X. That is precisely what the government of Maharashtra has also done, where they produce a bill to every department based on their usage of the infrastructure, and depending upon how much they use, the end user pays just like you pay for electricity or any other consumption of any other utility services that you have. And the third state is when once you do this, then you free up a lot of time, you free up a lot of resources, you free up a lot of budgets to start thinking innovation. Do we need to get data from different pools together? Do we need to kind of build in some business intelligence systems? So the money that you save and the time that you save, instead of going behind those mundane activities of just keeping your hardware up and running, is where you invest in terms of bringing in meaningful solutions and bringing in value from IT perspective to run the business. And if you look at the kind of transformation that we are talking about transformation in three layers, sorry. The first one being the infrastructure layer. In the infrastructure layer, we are looking at the traditional way of automation to moving to the cloud. In the application side, we are looking at new ways of building application, given the fact that social media and a lot of application demand today is to have an app store rather than deliver application like we do in the past. And the third area basically being mobility, where we have these plethora of devices hitting us, and as IT, we need to manage these devices and deliver the application on any device, on any operating system, and on different form factors as well. So this is the kind of transformation that we are looking at in 3 different layers across our data centers, and these are the demands that end users have today. But how do we address these demands, given the fact that we have an existing infrastructure, we have legacy, and we have challenges in the given legacy, and we need to move up to manage these demands of today's world. The world is looking at more than 90% virtualization in future.
Now, the reason why this technology has been adopted so widely is the first thing being, as the speaker from Dell, Suraj, was talking about use of commodity hardware. We have built the whole thing on commodity hardware, which is not proprietary. And the second thing is virtualization helps you bring all these pieces of hardware together and just create a platform. It could be vendors of different makes. Doesn't matter, it's just x86 platform that is coming together, and you have an elastic platform based on commodity hardware, nothing proprietary about it. The third reason why it is very successful is a lot of things that you do in today's data center, which is physical, is automated in the virtual world. So whether it is security, whether you talk about downtime, whether you talk about storage migration, all these things are automated in the virtual world. So essentially what it means is it frees up a lot of time for you from your daily mundane activities that you are used to. So that is the reason why you see this momentum worldwide, where you are going to see more than 90% virtualization in the next couple of years. And if you look at the time to provision new services over a period of time, in 2008, we were looking at weeks to provision a server, for example. In 2012, today, we are looking at days and hours. But at the same time, the paradox in this argument is when we are talking of virtualization today, and we are talking of the e-governance applications that run on top of x86 servers, we are still touching the compute and the memory. The network, the storage still continue the way it was over the last 10 years. So that has not changed by much. So what we need, when we are talking cloud and we are talking software-defined data center, which is an architecture for cloud, we are talking self-service. A self-service cannot mean provisioning in days and hours. It has to be in seconds. If an end user clicks, it has to be provisioned. So given the fact that networking and storage still involve manual steps, to give a real compute to an end user does involve pieces of those infrastructure as well, which is precisely where the focus of VMware is, as to how do we automate the network bit, how do we automate the storage bit, so that when we give away a infrastructure piece to an end user, we are not only giving the compute and the memory, but also the networking and the storage and the security that goes along with that in a virtual format, which is completely automated. So in future, what you will see is you will see provisioning in minutes and seconds that goes beyond compute and memory to including storage, to including networking as well, and security. And that is where the promise of the software-defined data center comes in. So all these components that are lined up on top, which includes the storage, servers, networking, security, and management and monitoring, will be available in virtual format. Already 50% of these are on virtual format. Primarily networking and storage is where we are working towards creating a software layer there as well, which will help us virtualize and do the same magic that we have done on the compute and the memory on those components as well. With that, we should be able to drastically reduce and be able to automate the data center to an extent that there will be a far greater simplicity than what you see today in a data center. So that is what we call as a virtual data center, where compare it to what you get from a co-location service provider today, where you get some compute, you get memory, you get a firewall, and he gives you some space. The whole thing in a virtual format is what a virtual data center is. So it is already available from VMware today, but you will see more evolution on that side. And primarily the evolution that we are talking about is in the areas of, for example, networking, where there is a new concept of software-defined networking, which is coming up. We acquired a company called Nicira, spent almost $1.3 billion a few months back doing that. So the ability of software to come into networking and kind of ease out the layer 1, layer 2 switching, and all you need is a far more simpler networking topology as compared to what you have today. Software will ensure the switching and will take care of a lot of those things which otherwise you have complex hardware that is available today, and you have to kind of live with silos of that hardware in different parts of your data center. In this case, it would be software which can easily slice and dice that and give you the ability to allocate networking as per the need be. Similarly, on the storage side, we are talking about how can we virtualize a lot of the components that are physical today, for example, the LUN. So these are technologies that you will see evolving over a period of time, which would be pieces of our software-defined data center, where you will see software having complete control of the data center and dramatically simplifying the way you run your data center. This is way beyond what we talk in the virtualization piece. And this is the problem that most people were talking about today, that we have created a lot of these silos in our data center. That is why it looks like a museum of the IT past, where every vendor, and it is not a fault of the IT administrator or whoever, these were application demands over a period of time. An application vendor came and said, I will work on Linux version 3.1. He said, I will work on Sun version 4.x. So for each one of those applications, you have bought different pieces of hardware, and today you're islands and pools of hardware lying within your data center, and you're struggling as to how to integrate all these and get meaningful information out of that you can use to take meaningful decisions in real time. Instead, if you look at a technology like virtualization that works on simple x86 commodity hardware, no matter who provides that hardware, it works across pieces and bunches of hardware that you can buy from at different points in time in different tenders, given the challenges of procurement in the government, and works across all the storage that you have in the market, all the networking vendors that you have in the market, and all the security vendors that you have in the market. The ability to create a pool of infrastructure where everything is homogeneous, everything is adaptive, and the ability to simplify a lot of processes in a data center that are otherwise complex to achieve, like for example business continuity, like for example backup, etc., etc. There is dramatic simplification in all these pieces as well, and the ability to slice and dice information, because now you have a homogeneous cloud platform on which your applications are running. You can have a pool of information where you can slice and dice those information in a fairly simple way without worrying about the proprietary nature of the platform that you're talking about. So if you see, we have used 3 principles in virtualization, which we are again using in our software-defined data center. We abstracted resources from the underlying hardware by introducing a piece of software over the servers. We pooled resources together, because now the application sees the entire maybe 20, 30, 50 servers as a pool of resources, including memory, including compute. All that is available as a pool to the application. And we automated the whole thing. So if you look at security, for example, the way this is automated, in the physical world, there are a lot of scripts running. In the virtual world, in the cloud world, we say policy-based provisioning. Why is it a paradigm shift from there to here? You take a virtual machine, you define the policies, throw the virtual machine in the cloud. For the lifetime of that virtual machine in that cloud, it will have the same policy. So virtual machines move. When a hardware fails, a virtual machine will move to a different hardware. In spite of it moving to a different hardware, and that hardware having virtual machines with a different policy, it will still carry the same policy that you have on one virtual machine to the other cluster that it moves to. So a lot of these things in a data center today are script-based, are manual, require people's intervention to do. All these are policy-based automation in a virtual and cloud world that we are talking about. And if I have to talk about the difference between a cloud and virtualization, why is a cloud a larger entity as compared to virtualization? We are talking about a lot more automation in a cloud as compared to what we are talking about in virtualization. We are talking about automating the disaster recovery bit. 3 clicks and you're off to the DR site. Instead of all those 14, 15 manual steps that you do, including natting, etc., the entire DR is automated in a cloud environment. Security, I spoke about one feature of security. There are multiple such features that can be automated in a security environment. Infrastructure as a service is all about providing the whole infrastructure as a service rather than worrying about the pieces of hardware or network or storage that you have. That is precisely what you achieve using a cloud as well. Hybrid cloud, that is another important area where a lot of our investments are going. For a burst capacity, you may want to have a data center somewhere where instead of procuring infrastructure and keeping it for a burst, you might just want to use a third-party data center only for a specified few weeks in a year. And that is the ability that we allow today, where not only can you automatically provision your private cloud within your data center, but also provision a third-party data center and maintain the security and management of that third-party data center in a similar manner as you are maintaining your security and management in your data center right within your premises. So the whole thing being automated in the form of a hybrid cloud. And when we talk cloud, we talk support for different hypervisors. Though we own 80% of the worldwide market, or the 80% of the worldwide production applications run on VMware, we still support multiple hypervisors, because in the cloud we have to be open, and we have invested in technologies that help us do that as well. And if you look at the self-provisioning piece, there is also a chargeback mechanism, which I spoke about, the Maharashtra government having the ability to charge back end users. It is again a critical piece, because that is where the metering comes in. And do you provide a service and you produce a bill based on the usage to the end user? So this is a dramatic shift where instead of trying to run a data center and trying to manage that hardware, trying to manage the upgrades, you are converting the whole thing to the form of a utility service where it is available on a tap to the end users. And even your ability to run it is a lot more simpler, because a whole lot of functions that are physical today are completely automated in the cloud environment, and it works like a song. So that's one of the key advantages that you have in the cloud. And it is not only restricted to this. You could have an infrastructure as a service, you could have a platform as a service, you could have a software as a service. We at VMware, we chose to go with a software as a service CRM a couple of years back. We moved to Salesforce. We don't own a single server of our CRM. With more than 12,000 people in the company, there's a hell of a lot of data, and that's the heart of our company, the sales data that we carry. But today, all that is run out of a third-party data center owned by somebody else, and all we get is a service out of that, and none of those servers reside within our premises. So a lot of successful models of software as a service there, a lot of successful models of platform as a service. We also built a platform as a service where you can come and run applications, and you can build applications. You don't need to even own servers. All you need to do is swipe your card, go there, build applications, and you can run it out of that. So we host servers and give you the ability to develop applications on top of that platform, which has those development tools and runtime tools, et cetera, et cetera. So these are different models that are evolving. Your cloud could mean a combination of infrastructure as a service, platform as a service, et cetera, et cetera. And if you look at some of the KPIs that we are looking at, and how do we measure ourselves and how do we better ourselves in this, so we are maniacally focused on reducing, the infrastructure cost per VM. So today we are talking about an average cost of maybe $1,000. How do we bring it down to $100? That is our future design goal. And if you look at the RTO, RPO, we are talking about less than 5 minutes of failure recovery. How do we bring that down to less than 1 minute with all the automation that we have? And if you look at the number of VMs per admin, this is again an important ratio. We have 300 VMs can be managed by one admin today with the automation that we have. We're looking at how can they make that 10,000 VMs per admin today. So the change that this is bringing about in the data center today is when there is a complex issue of performance management, etc. Many of our customers are saying it takes a few seconds to bring a VM up in another data center. It doesn't matter where the VM is running between 3 of our data centers. Just delete that VM, start the VM in another data center, rather than having hours of conversation on whether it's a database issue or an infrastructure issue, etc., etc. This is a paradigm shift that it is bringing. You're talking 12 core processors today with x86. In another year's time, you'll be talking 24 core available at a similar price. So the kind of VMs that our customers are running today is anywhere between 20 to 220 VMs per server, depending upon the kind of applications. So with the 24 core available in a short time, and with the kind of price performance that we are seeing in the x86 side, we are going to see a lot more density given in the racks, and a lot more applications going to run in little infrastructure over a period of time. So this is again, virtualization is bringing that wave, cloud is bringing that wave where you will see a density which is unheard of in a short span of time with the kind of developments that are happening on the infrastructure piece. So I will now shift gears to the end user and what virtualization is doing to the end user world, or the desktop world, as we say. So this has been one of the key technologies that came in a few years back on virtualization of desktops. And the reason being, like Steve Jobs declared the end of the PC era and brought in the tablet, and that has revolutionized the way we are looking at a desktop today. But again, it's the same concept. It's like desktop as a service. Wherever you go, your desktop follows. So that is precisely the change. And how this has happened is, again, decoupling the operating system from the hardware. That is precisely what virtual desktop is. We are bringing in a layer of software and saying, the hardware can be a dumb piece of hardware, it can be a thin client, it can be something without a memory, it can be something without moving parts. All it does is it displays data, and all the compute happens in the back-end data center. All you're doing is beaming what is happening in the back-end data center right at the front-end desktop. This will ensure that your data is lock, stock, and barrel in the data center, and all the security that you have in the data center will take care of that. It is not lying in multiple hundreds of desktops within the organization, and you're concerned about security of the data in all these desktops. Similarly, one of the challenges that organizations have today is all the devices. There are Android phones, iOS phones, etc., and there is a demand to provide application access on all these phones in a similar fashion as it's available in a laptop or a PC. So how do you manage this? As one of the technology challenges is there are different operating systems, there are different form factor devices. Will the application look similar? Will it feel similar on all these devices? Is the security compromised if we are providing access on all these devices? So these are some of the challenges that we are seeing in that space. And we did a couple of major acquisitions to help solve some of those challenges. So basically, in a nutshell, what we are saying here is we have an app store. We have an app store, so the fundamental change here is if an Apple can provide an app store and give access to thousands of applications for us across the globe wherever we go, and an ability to download and run applications, or an Android can do that, why can't we do that for our internal IT users? So this is an app store where when you log in, you will see all your applications in a central repository, and irrespective of the device that the user is using. He might be using a tab, he might be using an Android phone or an iOS phone, he will still see all the applications in a central repository, and this is a single platform from where you can provide a workforce mobility solution.